Topic 2 Microscopic World 1. Students will learn basic chemical principles by studying the structures of atoms, molecules, and ions and the bonding in elements and compounds. Students should also be able to appreciate the interrelation between bonding structures and properties of substances by learning the properties of metals, giant ionic substances, simple molecular substances and giant covalent substances. This chapter states the relationship between element and atom. Elements classified as metals, non-metals and semi-metals describe the structure of an atom in terms of protons, neutrons and electrons. Define atomic number, Z, and mass number, A. In terms of the number of protons and neutrons, state the relative masses and charges of protons, neutrons and electrons, as well as their positions within an atom. Identify isotopes among elements with relevant information, and define and perform calculations related to relative isotopic masses and relative atomic masses. An element is a pure substance that cannot be decomposed into simpler substances. Each element is made up of only one kind of atom, for example, lithium. All substances are made up of extremely small particles called atoms, since atoms are too small to be seen by the naked eye. Now, just like living organisms are made up of lots of tiny cells, everything, whether it's living, non-living, or even a cell itself, is made up of lots of tiny particles, which we call atoms. In fact, they are so tiny that a single cell probably contains more than 100 trillion of them. Elements can be divided into 3 groups. 1. Metals. All metals are solid. For example, sodium and silver are solid, and one exception is mercury, which is in a liquid form. 2. Non-metals can exist as solids, liquids and gases. For example, sulfur is a solid, bromine is a liquid, oxygen is a gas. 3. Semi-metal, or metalloids. For example, silicon. Silicon is widely used in making transistors. Some typical differences in physical properties of metals and non-metals. Appearance. The surface of a metal is shiny, non-metals are dull. Physical state at room temperature conditions. Metals almost are solids, except mercury is liquid. Non-metals usually are gases or solids, except bromine is liquid. The melting point and boiling point of metals are usually high. The melting point and boiling point of non-metals are usually low. Metals are usually malleable and ductile. Non-metals are usually brittle, which is easily broken in a solid state. Non-metals cannot be malleable and ductile. The thermal and electrical conductivity of metals are usually good. The thermal and electrical conductivity of non-metals are usually poor. This here is the periodic table, and each box in the table represents a different type of atom, which we call an element. So, this box here represents the element calcium, and this one is the element sulfur. We call these boxes nuclear symbols. And they tell us a whole bunch of information about the element. To see exactly what they tell us, let's take a look at the nuclear symbols of hydrogen and helium. The first thing to notice is the elemental symbol, which are the 1 or 2 letter symbols, which represents that element. So, H represents hydrogen and He represents helium. What are atoms? We can't explore just what these atoms are, and what they are made of. The first thing to know is that each atom is made up of multiple smaller particles, and its basic structure is a central nucleus surrounded by electrons, which orbit around the nucleus in rings, that we recall as shells. Although we have only shown 3 electrons orbiting here on the left-hand side, in reality, all of the electrons would be moving all the time. The nucleus itself is made up of 2 different types of particles, protons and neutrons, which are packed together in a tight ball. Now, the most important thing to remember here is the structure of the atom that we've just been through. An atom is in some ways like a small-scale solar system. The nucleus, like the sun, is at the center. Electrons, like the planets, move around it. The size of an atom depends on which element it is, but basically, they are the different types of atoms. The protons and neutrons have the same mass, so we say that they both have a relative mass of 1. Electrons meanwhile are comparatively tiny, and have a mass 2,000 times smaller, which is often written as just very small, or sometimes even zero. In general, we can say that atoms have a radius of around 0.1 nanometers, that we have drawn on the left-hand side. We have 2 protons in the nucleus and 2 electrons orbiting it. Protons are positively charged but neutrons have no charge. The nucleus is hence positively charged, and electrons are negatively charged. Because the number of protons and electrons is equal, the positive and negative charges balance out, and so overall the atom is neutral.